Hey guys, welcome back to my YouTube channel. My name is Abednego Vidolo, or AV going places on all platforms, and welcome to my YouTube channel. Thank you guys for the support on the last video, and today I'm answering one of the top comments, which was the only comment that was a question. But yeah, I know you guys are gonna ask more, but basically the only question that was there was, what do mechanical engineers do? And that's what we're gonna get into today. And so before I get into anything, I'm gonna give you guys a quick background on what I did and who I am. And so I graduated high school in Kenya. I was gonna go to University of Nairobi to study civil engineering, but we ended up coming to the US back in 2018. And so I ended up going to a community college instead here in Virginia, spent two years there and got my associate's degree in general/mechanical engineering. And basically I was supposed to do civil engineering and transfer to some different schools, but there's two main reasons that I did not. And one of them is VCU, which is where I ended up going. They gave me $20,000 in an academic scholarship. So that was a big deal. And then two, I also watched some videos and stuff. And since civil engineers do more buildings and stuff like that, I ended up seeing like they get on top of buildings, they get really high sometimes, and I'm not good with heights, so I was like, nah. And then so those were the two main reasons, but it ended up working out. Right now I ended up working in construction, and so I've been designing for systems in the construction world, even though I'm a mechanical engineer. And so today I'm going to talk to you guys about what I do and what other engineers do in general. And so basically in school, you're going to have a lot of math in your coursework at the beginning, and then you're also going to have engineering classes like thermodynamics and fluid dynamics to understand kind of how things work in the world. And then you're also going to have classes that teach you how to use certain software, like designing software like AutoCAD products and things of that nature. And then you're also going to have stuff like ANSYS, which teaches you how to analyze different things like flow and heat, same things with that software. And so, but the main thing I would say, like those AutoCAD classes, those Revit, SolidWorks, classes like that, Inventor, those are the main things that you'll probably use in the real world once you graduate. And so basically I'm gonna go step by step to what mechanical engineers do, giving you guys example of what I do personally. And in general, what I would say is all engineers basically do is use the knowledge of math and science to solve real world problems, and mechanical engineers basically just do the exact same thing but for machines that use or produce energy. And so you can do HVAC systems, cars, airplanes, rockets, phones, any of those machines. So that all fits into mechanical engineering. The first step that we go through once you're a mechanical engineer is identifying the problem. So right, what's not working, or what needs to be fixed, or what do we need, what's the problem that we need to find a solution for. So like in HVAC or MEP, which is mechanical, electrical, and plumbing, the main thing is number one, making sure the room temperature is like comfortable, not just the room temperature, but also like things like humidity. And then also we also do like plumbing and piping, so making sure people get clean water, and all the wastewater is safely removed from the building, right? And so that's the problem that we're trying to fix. And then the next step that you do is to try to now find a solution. And to find the solution, we design something. And so how you design when it comes to MEP roles is, you number one, we visit the job sites, we take measurements, we take pictures of equipments that are existing there if it's something we're trying to improve. And then if you don't even have an existing building, maybe you can just look at the plans, you can measure the areas, take a look at sizes of windows, directions of the windows, all of this good stuff. And what we do is we use load calculation software. We use Train Trace 700, and what you do is you take all those parameters, like how many people are going to be in there, what types of equipments are going to be used that maybe produce heat, the windows, the direction the building faces, and you put it into Train Trace 700. And basically, depending on the system type that you chose, it's going to spit out information on what types of systems and the sizes that you should use for that building. So that's the first step, just doing that, like designing for that calculation. And then after you do that, now you go into putting that on paper. So you put those different pieces of equipment, whether it's VAV boxes or air handling units or rooftop units, putting them on papers depending on the floors, and doing a rough sketch of maybe like the routing of the duct work and all that good stuff. And then if you have like a junior engineer, this is what I did mostly. I did the drafting of, now you just get like those sketches or plans with like red lines, and then you just put them into Revit and start designing based off of what your boss or the engineer, the professional engineer has done. And so if you're a junior engineer or you're a drafter, most of your first couple years will be spent just designing on Revit, following instructions from your boss or your higher ups. And so that's basically what I did. So after that, you put it into Revit, you start designing in Revit. You know, Revit is just like a 3D modeling software. Like you can see things in 3D or 2D, but it's the most popular one in MEP. And so using Revit, you're able to design HVAC systems. It has headaches, like sometimes it just doesn't work the way you want it to, but after you get used to it, it's a very, very powerful software. You can design your HVAC systems, you can route all of your duct work, you can route your piping systems, you can change colors of everything, you can identify things, you can put plumbing fixtures that are on there, you can import families from outside, like different equipments, like online, you can just download them and put them into your project. And so it's really good for that. And then you can do different things to avoid clashes, like you don't want pipes and HVAC systems clashing, so you can do coordination in there. And that's also something big in MEP. You and engineering, you work as groups, and that will be shown even in your educational journey. You'll be put into groups because you're gonna learn how to communicate with different trades, different types of people when you're working in the same project. And so, and then after that, you basically want to test the system. And so in different engineering programs, like I said before, you can use ANSYS, and that helps you test like different materials, how it's going to work for your project. It can help you test like how the airflow is going to work, how the heat is going to be produced, and all of that good stuff. And then after you test, now the next step is you build. So in HVAC, since we work with the contractors, you'll have the mechanical contractors, like where I work now. They'll take those drawings and those 3D models from you, and now they'll start, putting together how it'll actually look like in the real world, installing those systems into buildings or retrofitting into different spaces that already exist. And so after you build, job's not over. Just like Kobe says, job done, job not finished.
You're up 2-0.
Job's not finished. Job finished? I don't think so.
Okay.
So after you finish building, there can be processes where you have a contract where you can have a couple of years with sign with the different owners, and you have to kind of follow up to make sure that everything is working smoothly. And if it's not, they'll send you back like how. So once they're installing it, if something doesn't go as planned, maybe there's space constraints and stuff, they'll send you back maybe RFIs or maybe different questions for you to redesign your system for it to work as you want it to work. And then after that, you can also improve the system in the future as technology advances and things of that nature. And so, yeah, that's what mechanical engineers do. Basically, in short, mechanical engineers, they design, they analyze, they test, they build, and they improve systems and machines that use and produce energy. In short, I could have done that video in one sentence, but I need to make it a little bit longer so that I can get more viewers. I don't even think that's how it works, but yeah, that's basically what I would have answered you guys in the beginning and cut to the chase. So that's what engineers do. That's what I did. But now I switched into project management for a mechanical contractor. And in future videos, I'll explain to you guys why I made that move and that decision. But when I was a mechanical design engineer, that was the main thing that I did. And in mechanical engineering, there's a lot more different fields you can go into, like automotive engineering to do the same things, but with cars. You can go into aerospace engineering to do the same thing with things that are in the air, like airplanes or rockets or satellites and things of that nature, or even like missiles. I know someone who's a missiles engineer, so you can do that. You can go ahead and do like marine stuff, like the oceans, things in the ocean, and like ships and that and things like that. You can do robotics, AI, all that stuff, the same thing. And then as well, Other than mechanical engineering, you can do civil engineering for buildings and stuff. You can do biomedical engineering for that's more like things that involve like medicine and stuff, things of that nature. Computer science, which is like more so coding. Somebody asked me like the difference between computer science and computer engineering, and the only big thing there is computer science is mostly like the software, and you'll get a job at, somewhere like, let's say, so yeah, computer science is mainly the software, so the things that you don't see but are in the computers, like the coding behind like making websites and apps. So you can work for like Meta, Instagram, things of that nature, developing software. Or you can do like computer engineering, which is the hardware, so like the monitors, the computers, the PCs, and the chips. So you can work for like Nvidia, Microsoft, Dell, HP. Those are companies that hire computer engineers. And then you can do chemical engineering, maybe something under like petroleum or beauty products, things that require you to mix some chemicals. Even companies in Richmond like Altria hire a lot of chemical engineers. And so, yeah, I think those are like the main like engineering routes you could take. But remember, guys, if you have any more questions regarding career or educational advice, just leave them in the comments, and I'll be looking out for the top liked comment so that I can feature it in one of my future videos and answer you guys and help you the best way that I can. So I hope this helped, and don't forget to subscribe to the YouTube channel, and I hope to see you in the next video.